At the U-motion laboratory at Umeå University, we investigate motion patterns in the short and the long term after anterior cruciate ligament injury. Our research shows reduced balance more than 20 years after unilateral ACL injury when compared to age and sex matched knee-healthy controls. Here we have two examples of participants recorded using motion capture when performing the one-leg balance test. The person on the left suffered an ACL injury more than 20 years ago. The person on the right is a knee-healthy control. In fact, over half of the ACL-injured persons in our long-term follow-up could not stand on their injured leg for 30 seconds. This was regardless of whether surgical reconstruction was included in their treatment or not. The lack of balance wasn't only isolated to the injured leg, but was also the case for their non-injured leg. Here we have examples of our participants performing a more dynamic test, a vertical hop. On the left, we have an ACL-injured person treated with physiotherapy only. In the middle, an ACL-injured person treated with surgery and physiotherapy, and on the right, a knee-healthy control. When analysing the movement patterns of our participants performing the vertical hop, we saw that all three groups differed from each other with regard to trunk, hip, and knee kinematics during vertical hops. In fact, both ACL groups showed lesser range of motion and inferior landing control compared to matched controls. We are also developing new standardized tests to evaluate dynamic knee stability using motion capture. Here we have an example of the standardized side hop test. On the left, performed by a knee-healthy athlete, and on the right, performed by a knee-healthy control. The athlete has shorter contact time during the rebound phase and greater hip and knee flexion angles during both landings, despite presenting similar dynamic knee stability. In fact, our research, and that by others, indicates that ACL injury does not only affect the musculoskeletal system and mechanical knee stability, but also damages sensory receptors in the ligament. This has impacts on the central nervous system, leading to reduced proprioceptive acuity and thereby impaired sensorimotor joint control. Such deficits, particularly of the contralateral non-injured leg, suggest altered central sensorimotor processes following ACL injury, probably contributing to the 30 to 40 times higher risk of re-injury compared to non-injured persons. We have developed a new functional obstacle clearance test which targets both the proprioceptive ability of the knee as well as sensorimotor control. The test involves stepping over obstacles of various heights with downward vision occluded and is designed to be eventually applied in clinics. We found that individuals with ACL injury stepped over the obstacle with more stereotypical and asymmetrical movement patterns compared to asymptomatic controls, suggesting a decreased ability to adapt their movements to challenging situations in real-life conditions. In ongoing research, we have successfully combined 3D motion analysis with simultaneous brain imaging using both fMRI and EEG to map brain activity associated with motor control. Our research thus indicates a trade-off between dynamic knee stability and performance after ACL injury. Training interventions to improve sensorimotor control that can reduce injury risk following rehabilitation and among non-injured sports people to avoid injury in the first place are needed. We plan to take the next steps towards this by developing and evaluating new advanced methods of motor learning that can be individualized to effectively reduce the currently high risk of ACL injury.